Hey, what is up, everyone? Today, we're taking a look at a theme that should be interesting to you if you're a human and you're alive, which I presume you most likely are since you're watching this video. If you're not, then you don't have to. If you're like a crab or a dog that stumbled upon the keyboard, you don't have to watch this video. But if you're a human and you're alive, I think this should be interesting to you because we're going to be talking about why do we die. Now, obviously, one day you're going to die. This is quite depressing to think about, but let's not try to look at it from a depressing point of view and a depressing perspective, and let's try to find the reason of why do we actually die, like why does this happen, right? Let's try and stay positive. So I really do recommend you watch this video. It's the inevitability you're heading towards, and I think it would be quite interesting at least to know why it's even happening. Why are you dying? Like, have you ever thought about that? Let's try and distinguish between how it happens and why it happens. You probably know that your cells exchange in your body, they age. They're not perfect. Okay, sure, you probably know that, but like, why? Why is it set up this way? Why is it set up the way that one day you are going to die? Have you ever really thought about that? Well, I have. So I've looked into it. Let me know in the comments before watching this video what's your theory on why we all head towards death before watching this video. Now, I'm not saying that I'm going to give you the perfect answer, but I'll try to make you a bit more knowledgeable about the theme, about why it's a bit more complicated than you might think. So let's get right into it. So first off, let's talk about why should we even care? Why the fuck do we care about us dying? Well, first of all, death, it it affects you directly. It will happen to you. It's this unimaginable event that you know will happen, but you can't really avoid and even like fully grasp. It's very strange. It's a very strange event. You may know some people that have already died in your family of old age. It's unfortunately happening to all of us. So it might be a bit more interesting to know, like, why is that even a thing that happens in our system or universe? Now, we will most likely be trying to talk about this philosophically and also biologically. But the result of this presentation at the end of the day will be that biology is not enough for this theme. But first, let's try and to grasp it more biologically, right? So there's this interesting theory that I had in mind when starting off. I know that a cell dies for the organism, right? So I thought that there would be this kind of hierarchical scale that you would die for the better of the higher organism, and well, that's somewhat true. But we will get into it. Don't worry. And I thought that, okay, so if a cell dies for the organism, what if we are no different? What if this programmed death, this clock in us that leads us towards death, what if it's the same thing, right? But maybe not. Maybe it's just a human construct, right? So first, we must look at apoptosis. So what the fuck is apoptosis? You might have heard about this if you had cellular biology or biology in high school. Now, the whole schmuck or whatever you call it of this is that a cell mostly, there's different types of deaths, but these are the two very common and known ones. Cell mostly dies to necrosis and apoptosis. Let's say you cut your hand. Now, some cells will die to necrosis, some cells will die to apoptosis. Now, what's the difference, right? Like, well, it's the same event. How come the death of those cells is different? Well, the necrosis death is like getting hit by a car. It's like, okay, well, the structure crumbles, it's beyond repair, you're fucked. Now, apoptosis is very different, and it's very hard to imagine because we humans don't really do that. But it's like this program that, let's say you cut your hand, right? And some cells get hit directly by that cut. Now, the ones that die with the necrosis, it's an inevitable chaotic death. But some cells, they're damaged, and they're damaged beyond repair usually. And what they actually do, they just literally just kill themselves. Like, that's what apoptosis is. And there's no, well, we cannot know, right? But apparently there is no consciousness behind it. There's no sentience behind it. It just kind of happens just for the better of the organism. It's just evolutionary programmed. So I thought, okay, maybe our death is the same thing. Maybe this whole thing happens for the better of the species, and that's kind of true. That is very important to know at the start, that is kind of true. But we will get into it more detailed. So one thing with apoptosis is to know that you might think that, okay, so this happens when you cut your hand, but does it like happen otherwise? Like, is this a necessary thing? Yeah. There's this one condition called syndactyly. I think it's a great example to show on this. Now, it's a very visual example. That's why I'm showing it. So imagine you're in the womb, you're developing, and imagine it as if you were a fish and you had a fin. I think that's like a great way to imagine it. your fingers are kind of conjoined, connected, and due to the apoptosis happening in the middle of those fingers, it forms the distance you have between them. So right now, when you look at your hand and you spread your fingers, the space you have between them, it actually happened due to apoptosis happening while you were in the womb. The cells were dying and they formed the distance in between them. If this fails, there's this one condition that it's called syndactyly, and you would have connected fingers. So you can look at it this way: like if we ask why does it happen, it's a genetic mutation. In case you are more interested in the specifics of how can this even happen, right? So it's a genetic mutation that the cells they don't communicate clearly, and there can be some kind of interruption of development in the embryo. Let's say your mom is like on methamphetamine. Well, you might turn out as a fish man. But what's the interesting thing here is that evolution, it's not a perfect thing. Like these mutations they happen, but we tend to view it as negative because we know what the program should be like. But if you look at it from the grand scheme of like earlier life, now I give this example of cacti, the evolution of cacti. I think it's a great example. The cacti in the desert, they used to have bigger leaves. Now there had to be this mutation. It probably was a mutation, right? But there had to be a variety of smaller leaves. That's how they got into the thorns, because evolutionarily they figured out, well, there's no conscience behind it, right? So it just kind of happened. But evolution, they reproduced the way that the ones with the smaller leaves, they turned out to have bigger survival and reproductory rates. Now when you see this, you know that these mutations they actually create new possibilities, and it might have, once again, I'm not that well educated in this, but in the past, it might have been that some kind of crazy mutation proved to be great for survival. Let's say when you look at this image, in case you're not watching, there's this image of a hand that's like completely fucked up. It looks like a fucking slime. That's one way your hand can develop when it fucks up really bad. Let's say this proved great for reproduction. Well, this gene would then be passed on. So that's kind of this whole idea of why mutations might even happen evolutionarily, right? Because they helped for more variety. So it's the way things are set up. It's kind of strange to think about an answer that seems to be kind of unsatisfactory to say that it's the way things are set up. Yeah, I get it. I get it. Some other examples of apoptosis. Well, your brain develops with extra neurons dying. Your immune system is pretty much just, the whole thing is your system is eliminating your own cells. So that's also a form of apoptosis. And daily, millions of cells are removed from your body in all various ways. It's just a natural process. You're a continuous scale of death and renewal, of self-regulation, of self-maintenance. It's this whole complicated system going inside. It's like I don't know if you've seen this one Rick and Morty episode, but he went into the human body of like some homeless guy, and there was like a fun park inside of him, and that's pretty much what your body is. It's a very complex system, right? So apoptosis, it actually helps you develop and properly function. So if it didn't happen in our current biology, that's what's really important, right? If it didn't happen in our current biology, you wouldn't be able to develop and function properly, right? It's the way you are set up. Now, here's the thing. What this then leads us to is to think that there's this kind of purpose behind death. You see that apoptosis, it helps your organism like this. It helps your body maintain itself. So you think that, okay, so maybe my death, it does the same thing. It makes space for new life. It enables evolution. There's this kind of social and ecological development that I'm allowing for. So maybe it's great that this death is inevitable, right? It's set up this way. Now, the problem this leads us to is that you might then think, well, it would be best for my species to kill myself. So yeah, that's kind of the trap you can fall into, and that's why it's very important to distinguish that, because you don't have to be sure with this. If you are sure with this, then it would turn out to think you're supposed to be a hero and self-sacrifice and kill yourself, right? But that's not actually the greatest move you can make for your species. I dare to say. I dare to say you can do much more by staying alive. The biggest question though is why? Why even like care for that? Right? Like why care for the evolution? Why care for your species? And that's more complicated topic. But let's continue with this presentation because we have to talk about this kind of result that you falsely fall into, where you think that death is necessary. Now, here's the big problem: when you say that necessary, it's impossible. It's it's quite literally impossible to call it necessary. At least for me, it's not enough. Like there's not enough because let's imagine that a cell can regenerate endlessly. It doesn't lose quality with age, and it can develop endlessly. Would it then have to die? No, obviously. Like if that cell that got cut died to necrosis, right? It died to chaotic death. Well, yeah, sure. Okay, that one I guess is necessary. But what about those ones that were damaged beyond repair? What if there was no such thing as damage beyond repair? What if they just could perfectly regenerate? They didn't lose quality with age, and they can just develop beyond infinity. Like what the fuck? Like there would be no reason for death, right? So death is necessary with our current biology and with the way evolutionary mechanisms set this thing up, but it's not universally necessary. It's this false presumption to say that death is necessary. It's just not true. It's just not true. It's death is a result. It's a byproduct, but it's not a necessity. We tend to view it this way, and I will get into it more. Okay, so listen. Here's the thing. When we ask why is it actually necessary in our biology, well, the reason is first of all some physical laws, entropy, and the reason that we have time. Now, if we didn't have time, things changing and leading towards something, this wouldn't have to happen, right? But we're in space time, so it's leading towards some kind of change. The whole point of time is change, right? And the way change works in entropy is that everything goes from being highly ordered to being more disordered. So eventually nothing can really keep this orderly structure in it. And also, you have some kind of biological limitations that lead us towards death. Now, if we want to talk about the biological limitations, we can get right into it. I have some very simple examples, the most mundane examples. I don't want to make this an overly biological presentation. I just want to, in short, tell you why do you actually die from a biological perspective. Right? So first, let's get into DNA damage accumulation. So the way it works is that DNA is found in every single cell. Now, DNA is a genetic instruction. In case you have heard about viruses, they go into a cell, they give it a different genetic instruction, and that genetic instruction makes it reproduce more of those viruses. That's a very simple way a virus works. So a DNA is just kind of a manual for what to do. That's the way I understand it, at least. Now, DNA, it damages with time. It happens due to UV light, due to chemicals, all kinds of stuff, right? Like, we don't have to really care about the details. The most important thing is that it damages faster than it is able to repair. So there is never the ability for complete repair. It's inevitable for DNA to die. And you might also think that, okay, so if it dies, doesn't a better cell just like become born? And it's just like if it's the same quality, yeah. Unfortunately, the cells they eventually go down with quality, right? The way they separate or reproduce is already called reproduction with cells. But let's say that because we're not biologists, right? So we don't have to care about that. Now, another important thing is that there's this limited repair capacity. This is actually tied directly to the DNA being damaged. Well, there's a limit to the repair. It's like set up this in this retarded way that even though every living organism is self-maintaining, the self-maintenance is not perfect. It's not unlimited. So eventually the structure crumbles. Now, another thing is there's this clear example of how this becomes damage. It's this thing called telomere shortening. In case you ever stumble upon some kind of pages that talk about the death, this will be most likely there as one of the examples of explaining why we die, even though it's not really explaining why we die, right? It's just explaining how it happens. Now, there's this thing, it's like safety ends of DNA. Imagine like you have a tie on your shoe, and there's like that plastic little end. That's pretty much what the telomere is for the DNA. Now, the DNA, they copy themselves, and with every single copy, the telomere shortens, and there's this thing called the Hayflick limit. So there's like a hard limit of copies that can be done until the safety end is not damaged beyond repair. Now, this can also be repaired with the organism. There's the example of the immortal jellyfish, which we will look into. Now, another thing is that there's actually a thing that can happen if the cell doesn't die. There's an alternative which tells us that a cell kind of for the organism is better for it to die. It's kind of similar to cancer cells, even though it's not the same. It's called cellular senescence. Now, the whole thing is that a cell can actually survive under big stress, but it then produces inflammation, which is obviously bad for the body. So it survives for itself, but it damages the whole organism. So you might think some result of this is that humans die for the ecosystem. I dare to disagree and say that age of death, like it's increasing with time, so it doesn't really make sense. Like if you were to think that humans were dying for the better of our planet, like wouldn't it make sense that our age of death would keep getting lower and lower, and evolution would just kind of like have this intact, for the better of the of the higher organism of the ecosystem of our planet? Well, that's not really happening, right? We're the senescent cell. We're our age is increasing. We're defeating evolution. We're defeating death. We're defeating entropy, like, and we're this is more the example of us. We're actually this whole thing, we're the ones producing the inflammation, right? We're damaging our environment and the higher organism, and that's not necessarily bad. We just live for ourselves. But if it worked universally in biology, then we have to realize there's this thing inside us, a cell, and it can do the same thing as well. Now, the last thing I want to say is oxidative stress. It's incredibly oversimplified. Don't throw rotten tomatoes at me, as you can see on this image. Now, the thing that oxidative stress is, there's this mitochondrion inside the cell. Now, mitochondrion, you might have heard, is the powerhouse of the cell. Okay, who cares about that stupid shit? What you just need to remember is that it produces ROS. ROS is a reactive oxygen species. Now, that doesn't tell you anything, right? You don't know what the fuck that means. Just think of it this way. You're the mitochondrion. You live inside a cell. You're probably inside some kind of room right now. Okay, so look around that room. Look around that room, and you see, okay, there's a broken, there's like a crack in the wall right there. Okay, so I'm gonna send a signal into the cell, into the room I am in, to say that there's a problem right there. There's a problem right there. Now, the worse the state is of that room, the more signals you're going to send into that room. That's actually what the mitochondrion is doing. And when it sends too many of these signals, apoptosis begins. There's this cell death, because the cell is like, fuck. Well, it's not. It's there's no conscience behind it, right? But the program behind the cell is like, okay, there's too many signals. This is fucked up. This whole room has a wall full of cracks. We're just gonna fucking die at this point. Now, why do we care about this? Why do we care about apoptosis? Well, this is where things get interesting. And finally, we go more into human death. So there was this one guy, rest in peace to him. He died not so long ago. It was a Russian biochemist. So clearly a guy that was very deeply into this. And his name was Vladimir Skulachev. Now this guy, he was doing a research behind death. He was trying to reach immortality. He had this like whole research. We might talk about him in future videos again. But what's important is that he came up with this theory called phenoptosis. Now you can kind of hear already there's kind of a resemblance between phenoptosis and apoptosis. So you're like, okay, so what can it be? Well, it's the programmed death, but he's saying it's for the whole organism, just not for the apoptosis, is for the cell. He says that phenoptosis is for like whole organisms. Now, there is this kind of idea that it's a programmed death, which would kind of serve as a sacrifice for the greater benefit. It would be an evolutionary programmed death that is a sacrifice for the greater of the whole species, right? And there would be no intent or awareness behind it. But it's just a hypothetical theory. We need to remember that. So how does this work? I found this one separation of it that lists phenoptosis into different types of it. We will show us some examples. Now, this is not exactly directly for Skulachev, just to mind, but this is from some kind of book. It separated phenoptosis into direct or indirect, where the direct one is that the organism kills itself. Indirect is that the organism kills a close relative. Now there's also optional or conditional phenoptosis. There's obligatory. That's like has to happen every time. It can be either rapid or slow. A slow example of the slow is aging. The writer of the book separates it into determined by biochemical mechanisms and determined by behavioral mechanisms. Now, this is just some kind of separation to see what it's like. But let's show examples that will make it more clear to you. So, example number one, I think is a very great example. Is an example of similarity. Now, this is what happens with Pacific salmons. Now, these guys essentially, just to put it into very simple words, they have sex and they put so much fucking energy into they just fucking die. Like they put all their energy into reproduction and then they die. Imagine that. Like imagine smashing some girl and you just die, like, or she dies. That would be even worse. Like I don't actually know what I would do if I had sex with some girl and she would just like die on the spot. Like I'd probably just like keep going. No, okay. No, I actually don't know what I would do honestly. Um, it doesn't even make sense though because she's the one doing the reproduction, right? But Jesus. Okay. So this can also be seen in octopuses. Now, the whole point of this is that evolution set it up that remember this in evolution the biggest priority is to reproduce, and with Pacific salmons the priority was so big they set it up that way. Well, nobody really set it up, it just turned out that way, that they put all their energy into one single reproductive event. It's also seen in some octopuses, by the way. So example number two is this indirect optional phenoptosis. It can happen, doesn't have to happen. It's the praying mantis sexual cannibalism. Now, this thing is even more wild to imagine happening with humans. It's like some beyond Jeffrey Dahmer shit. So the female praying mantis, it's just straight up like it just goes like full on Kung Fu Panda, and it fucks. It has sex with the male praying mantis, and after that, it just kills him and eats him. Apparently, this is supposed to boost her fertility, like she gets the nutrients from him. It's like, okay, interesting. It's also seen in some spiders. So once again, the whole point is reproduction as the top priority. Now, next up, flatworm stressing too much. This is a direct optional, once again, optional. Now, again, phenoptosis example is that there's this one tiny worm. It's a centimeter long flatworm, kind of reminds me of my penis. And what it does is like just straight up chilling in fresh water. But when it's under extreme stress, it eats itself with this process called autolysis. Now, the enzymes you have in your stomach, they just flow out and they kill cells inside this flatworm. Once again, this is an evolutionary program of I'm gonna die. It's kind of similar to apoptosis, right? Dying for, I guess the purpose would be freeing space for better flatworms, even though I don't really know how exactly, like, why is the reason behind this being set up this way? Like, why can it just like not endure extreme stress? I don't know. It's interesting. It's interesting. You know, this would kind of suggest that people committing suicide, if you don't believe in free will, which is very hard to believe in, honestly, it's getting more and more harder. If you don't believe in free will and you think that everything is determined, everything is programmed, you know, suicide might be a program as well. That's an interesting way to think about it. So, and lastly, mass bamboo death. Now, bamboo, the way they work, they're just chilling for 120 years. They're in this vegetative phase. They're doing essentially nothing. And then suddenly, there's this kind of fucking invincible biological clock. All of the bamboos flower, and then they all start dying. Once again, priority is in the reproduction. It's kind of similar to the semiparity example. It's called synchronous flowering, by the way. Now, Skulachev, he comes up with this theory, and he sees all these like behaviors in organisms, and he sees that what they're doing, the max priority is that they essentially put all their priority into reproduction. That's where all it is. And this might even explain for humans why, for a lot of people, the purpose of their life and what brings them happiness is children, is actually having children. That would explain why evolutionarily it was set up. It was set up for reproduction, right? Now, Skolochev, he said that human aging is actually a form of slow phenoptosis. It's this irreversible biological decline that leads you towards death, and it's possibly beneficial for our species. You know, for population renewal, evolution, materials. And I'm not quite satisfied with this example. There's a better way to explain why it is set up evolutionarily this way. We will get into it, and we will actually find a solution to this problem. But right now, I'm like, okay, this doesn't really satisfy me, because doesn't like everything age? And then you look at the immortal jellyfish example, and you think that, well, why is it set up different in this way? It's clearly not universal. So that's very strange, right? So why do we age and this thing doesn't have to die? Now, in case you don't know how it works with the immortal jellyfish, there's like a shit ton of videos about it. But the very simple thing for me to explain is that it has this kind of life cycle. It goes from the egg to the planula to the polyp to the different polyp. I don't fucking know. I'm not fond in jellyfishes, right? Go watch SpongeBob if you want to learn about that shit. But the important thing here is it can reverse its cycle. Now, it's in the adult phase. It reprograms its cells to different cells, and it can reverse back to the polyp phase. It's like if you suddenly just now reversed back into being 10. It repairs the telomeres, we talked about the safety ends of the DNA, fastly, and it can repair them before it's beyond repair, and they can, in theory, attain immortality. Now, scientists, they're putting a lot of effort into looking into these guys. Fortunately, we have amazing people that look into this, and they're trying to figure out how this works. So maybe it's the goal for our immortality as well. And I think that the very interesting thing to talk about in the next video is, should we even want immortality? And is it even possible for us to not want immortality? Have we always wanted immortality? Is it just part of the human nature? Now, that's what we will be talking about in the next video. I really do recommend checking out that one. It's going to be very great. But now we see this and we see that, okay, so that's interesting. So evolution set it up that this fish, for some fucking reason, doesn't have to die. So that just tells us that even with our current biology, like death, it's just not necessary. So once again, we see that why the fuck do we age? So we're even more confused right now. So now you realize you're gonna die one day, and you see that, what? Why am I not a jellyfish? So another example of a theory that can come into mind intuitively is that there's this evolutionary advantage of death. Now, yes, this is true. This is the key to discovering this. But I think there's a wrong way of seeing it. Let's say there's like a environment where a zebra attacks every single day. Now, one guy has 5 children, and he has a variety of his genes spread into the children with different survival odds against a zebra attacking, right? Now, he has a child that has a 99% chance of surviving against a zebra. Now, this obviously proves great for reproduction, so that child has more children. Now, a zebra attacks, it kills all the other children, but the guy, the father of the child with the 99% chance of surviving against the zebra. Now, I really do recommend watching the presentation for this example. It's kind of hard to follow, just in mind. All the children die. The father has a 50% chance of surviving against the zebra, but he can actually become protected by the children that have a 99% chance. So why is then a necessity for the old to die? The whole point of this is saying that, okay, sure, I get it. You need to have a variety of genes. Reproduction is a priority. I understand that. But if you have already proved successful for your species and done the maximum perfect reproduction, you can keep reproducing till it's better and better and better. Why does the old need to die? There's no necessity for it, especially when it would die naturally. Let's say you have some materials that are limited for keeping the body. Let's say you have 4 people right here. The old guy, he had a 50% chance of surviving a zebra, since he's now protected against the zebra by his children that have a bigger chance of surviving against it. He has immunity. But let's say there's only 3 pieces of food. Well, only 3 of the best ones would survive. But still, that doesn't really answer if, like, why is there a need for an internal death clock when it would just happen naturally? Like, you would run out of food, what the fuck? It would just get resolved. There's no need for things to be set up this way. Now, that's pretty much the whole point of this presentation, to say that there is no need for death to be set up this way, but it is. But it's not necessary. Death is not necessary. That's the whole important point. of asking, and we will follow into it with the immortality presentation to say that, okay, if it's not necessary to be this way, should we then strive for immortality? Now, one counter argument you can make that is that death allows space for younger humans, and I dare to disagree. I say that, okay, space would be allowed by natural selection. We would just kill each other, face a lack of resources, die to hunger, overpopulate. There's no reason for death to step in. Like, this would just get resolved by the own species, right? Next example of a counter argument you can make to this, of me saying that death is not necessary, you would say that death allows evolutionary adaptation. No, that is not true, as we have just shown on this example. Evolution needs genetic variation, heritability, reproduction, and whatever gene proves best for survival is passed on, but there is no need for the old gene to die. Let's say the old ass monkey, as you see in the evolution pictures of the human, just like standing more and more straight, like the old ass monkey we were once before can exist right now. There's no need for that guy to die. I wouldn't personally care. What the fuck? Now, another hypothesis is that, to connect this with the apoptosis, is the Gaia hypothesis, which essentially says that the Earth is a superorganism. Now, Terence McKenna, if you are in the psychedelic community, was really fond of this, but Terence McKenna also said that the Earth will end in the year 2012, so I don't think that's very relevant. But the whole idea is that to say that the Gaia hypothesis is oh, shout out to all the One Piece fans, by the way. I think there was like a Gaia or Jaya, what was it? Not sure. So the whole theory is that the Earth is a superorganism, and we see how programmed cell death helps us individually. So we might think that our death may be helping Earth the same, or the ecosystem. And yes, our death is kind of helping. Well, it's not really helping anything. It's just set up evolutionarily. It's not really helping evolution. It serves evolution. Like, yeah, I guess that would be a way to phrase it, maybe. But even if this were true, why isn't death universal then? If this is true, why isn't death universal? Why do some organisms age more? Like, why does a turtle age up to 200 years, and why is the jellyfish immortal? Now, you might say that they don't have this amount of ecological impact, and well, it's an interesting argument to make, but then we can then go back to the earlier point we learned earlier. Then why do humans, with the more negative ecological impact they have for the Earth, why do they keep aging up to a higher age? That wouldn't really make sense, right? Now, finally, we get into a more philosophical counter argument saying that death gives life meaning. Now, I think this is my personally favorite one right now, because it's a different point of perspective of asking this. Now, obviously, this is wrong, but well, it's not obvious, right? But it is wrong. Now, the counter argument would be that what would be the meaning of life of something that would be infinite? What would be the meaning of something infinite? Yet we hope for afterlife, and we have never not existed. Like, think of a time where you were dead. Well, that never happened, right? You were always a Dasein, as Martin Heidegger would say. You were always here, always alive. Okay, well, great. Now what? You say that the meaning of something infinite. What would be the meaning of that? Well, your life has been infinite. There was nothing as not non-life, right? And like, why have you not committed suicide? Now, maybe you would if you got old enough, but maybe you wouldn't. Who knows? Who knows? And it's interesting. I even have this one friend that said to me that he would actually like to be immortal. That's kind of like, it's, he thinks about it a lot, that he will not see humanity evolving, and that's interesting. I never really thought about this, because you can imagine how the Earth will look in 1,000 years, and you imagine all the scientific stuff that will be there, all the new technologies, but you won't see it. You won't see it. That's, I guess that's kind of sad to think about. So yeah, you say that, but like, our world revolves around death, but it's all we know. Like, we don't know anything else. How can we never say that a world where we would be immortal would not have meaning? Well, you can always kill yourself. And would you then do it? I don't know. Honestly, like, a lot of us are hoping in our mind for an afterlife anyway. So it's kind of hard to say that death gives life meaning, where we always avoid death. And would we find meaning in an eternal life? Well, it's very tough to say. Like, are you doing what you're doing right now because you're alive, or are you doing it because you will die one day? Oh, that's another great counter argument, that the knowledge of your death is maybe why you're doing a lot of stuff. At least I am like approaching life that way. So maybe maybe this counter argument is not that bad. Once again, though, it doesn't really prove that death is necessary, but it proves that it has a positive on the human life. The knowledge of death, at least. I wonder what it would be like not knowing that you can die one day. And maybe you will die tomorrow and you don't know it. Okay. It's another way to see it. Okay, so it's very interesting. Maybe this is more complicated than I thought. Now, the last counter argument, and this is the best one, and it's actually a true one, is that it's an evolutionary trade off. That's why we die. Now, the counter argument goes this way: death is the resolution of evolutionary, in quotes, programming. Once again, it's not a program, right? It's a trade off. Now, there's this thing called antagonistic pleiotropy. I think it's read. And the way it works is that when we go back into evolution, genes that were chosen to be beneficial in youth for us to reproduce actually had the trade off of being bad and harmful later in life. But it proved better for reproduction, so it stayed. Let's say that we did IQ tests and only people with like 150 IQ would reproduce. That gene would then prove better for the species. We can do like a forced evolution of something, right? That's pretty much how we domesticate animals. It doesn't really happen though. It seems that more stupid people have children than more smart people, and that's why more people are becoming fucking retarded. I don't know. I don't have this proven. Maybe it's not true. Maybe people are becoming more intelligent, right? So that's the whole way it works. Like whatever reproduces, it reproduces and passes on. And there's one theory behind it that the gene that was beneficial in youth, harmful later in life, passed on. And it even makes sense because you don't really reproduce later in life. If only people that somehow if we somehow knew whoever is going to reach the oldest age of like 100 and only those people would reproduce, I think we would attain more and more age with time. I don't know. Now another theory is the disposable soma theory, and this whole thing is that evolution once again prioritized reproduction over maintenance. Your body, there's no need for it once you have reproduced. As I have said before, there's no need for it to die. But on the other hand, there's no need for it to survive. And reproduction and evolution, it turned out the way that it prioritized that someone reproduce over someone actually maintain themselves, if that makes sense. So it's kind of this whole retarded ass process where we all reproduce just for the sake of reproducing again and again and again and again. And that is so fucking strange. Like, oh, if we want to find the purpose of your death, of why you die, we have to go deeply into evolution and into philosophy because biology has not been enough for us. We have learned today in this presentation that death, you would think that is necessary, but it's only necessary in our current biology. And you know, it's not aging is not a program; it's a byproduct of evolution. It's the way things turned out for the better of reproduction. It was better. It wasn't even better. It was just like a trade-off for the higher chance of reproduction. You die, and that's kind of fucking depressing, honestly. That's kind of fucking depressing to think about that. Now, that doesn't mean that there's no purpose behind your death. It doesn't serve no purpose. It doesn't mean you don't have to approach the knowledge of you dying someday in some kind of way. And we'll try to talk about this further on. It's very sad though to think about it this way. So you might think that death is unavoidable. No, we may defeat it, just like the immortal jellyfish. Now, also you might think that death serves a purpose, and yeah, it has benefits, but we cannot really say that there's like a grandiose higher purpose than us. Maybe there's not. And another common belief that I wanted to break with this, and that we got to break with this, is the belief that it's that simple that death gives life meaning. It's not such a simple equation. It's more that knowing death, knowing you will die one day, knowing there is an end coming, the knowledge of death gives life value, right? It's not the death alone. It's not the thing alone. Let's say that you knew you will die one day. You would live your life completely differently, but that doesn't mean that death alone has to happen. Like you live your life as if you die, but you still wish for an afterlife, and that's uh, that's I guess our nature. So, if this wasn't depressing enough, I hope it wasn't, and I hope you disagree with me in the comments. Please let me know. In the next one, we will be talking about should we want immortality. We learned that death essentially is just a byproduct of evolution, and that kind of seems to tell us that life has no meaning. And I kind of want to circle out of this and get out of this trap, because it seems we're trapped in nihilism right now, and that sucks. That fucking sucks. So let's try and figure it out, and maybe we won't. Maybe we will just be stuck in knowing that life has no purpose, and maybe not. Maybe we will get out of it. So next up, we maybe we'll talk about should we want immortality. I'll think of it, but I think it's the way to go with this one, because now we know that since death is just a byproduct of evolution, well, do we have a chance to turn it around? And should we then want to go against evolution and want immortality? Is it something we should even want? So yeah, thank you for watching, and I'd really appreciate if you subscribe. If you don't, you're gay. Okay, see you.